Thanks for joining us today for our annual SC Breakfast Briefing. I'm not Jaclyn Ludema, our lead analyst covering sustainability and energy efficiency in HPC. I'm Mark Nosikoff, Research Director at Hyperion, pinch hitting for Jaclyn on trends in HPC sustainability. Let's start with takeaways from recent research. We're seeing three primary areas emerge as priorities for HPC data centers relative to sustainability. The first area is under the overall umbrella of sustainability, which includes sourcing of renewable energy, circularity, which encompasses reliable sourcing of materials and responsible system retirement plans, corporate mandated ESG goals, and innovations resulting from use of HPC resources. Energy efficiency is a second area, which includes reacting to prohibitive energy costs, smart power management, efficient hardware design and configurations, and liquid cooling, including water utilization. The third area falls under a category of doing more HPC with less. Efficient code design, optimizing complex workloads, and leveraging telemetry data, which would also be included under smart management, fall within this area. Specific areas seeing an increasing amount of attention include sustainability-related outcomes from HPC-related research and engineering, system telemetry related to power consumption, water utilization, and circularity. Innovations addressing sustainability, particularly HPC-related research and engineering applied to worldwide environmental concerns, are increasingly top of mind. Digital twins of the various Earth systems, land, oceanic, and atmospheric, are leading to an increase in understanding of both the independent and interrelated relationship of natural and human impacts on the environment. Minimized waste in the research and development stages of product design is being achieved from adoption of HPC-enabled, with and without AI augmentations, modeling, and simulation. The environmental impact of exploring for and extracting oil and gas is being reduced from application of evolving HPC techniques and applications providing more precision and accuracy of models. Additionally, data centers are being required, either by corporate mandate, client requirements, or governmental compliance, to provide assessments and scorecards relative to site sustainability. There is a strong desire that positive environmental outcomes from the research and engineering occurring within the data center be included as part of the assessment, in addition to the current energy consumption and carbon footprint reduction metrics. To a certain extent, telemetry is already being captured and utilized, but there is a desire for more visibility into energy consumption impacts. In the absence of any power consumption data, users will gravitate to completing their tasks as fast as possible. In many cases, code could be written to consider the energy draw of a job, and a decision could be made to either optimize the job for highest performance or lowest energy consumption. Data center operators are also considering different payment models for the use of the facility. For example, TAC is exploring an energy consumption model as opposed to the more typical wall clock hours model. Additionally, having greater insight into energy consumption and power utilization can assist in the evaluation of energy performance trade-offs of porting code to GPUs, inform decisions relative to when equipment should be retired, and making energy use comparisons between on-premises and cloud-based resources. As power requirements for the highest performing CPUs and GPUs are approaching and exceeding 1 kilowatt per socket, liquid cooling is becoming a de facto standard. With that comes a new concern relative to the sourcing of and efficient utilization of water-based direct liquid cooling. Several proof points exist for multiple ways to approach this. Gray water systems can be adopted with on-site filtering. Argonne National Labs has taken this approach and substantially reduced their potable water intake, saving $1.2 million annually. Warm water evaporative cooling systems can also reduce water demand. NASA has taken this approach and saved 5 million gallons of water annually, along with millions of kilowatt hours. Circularity, which takes a cradle-to-grave approach to evaluating the sustainability of a system, is becoming a common criteria that sites are including in their requests for proposals and tenders. Circularity includes evaluating a system vendor's or CSP's responsible sourcing of material, energy consumed and carbon footprint of a system's operation or the completion of a particular job, and plans for retirement of the system at the end of its useful life. One byproduct of this is the consideration of extending the equipment's life, both in the vendor's design stage and a data center's operation stage. These are just some of the trends occurring relative to the important topics of sustainability, energy efficiency, and carbon footprint reduction. Look for continued and expanded research in these areas in 2024, including a broader examination of relevant and useful metrics. Thanks again for joining us, and enjoy SC23.